Woohoo, and welcome back. Today we're going to be talking about combining functions in a very, very special way that is called composition of functions. Woohoo! So we're going to start off with this big gobbledygook mess of parentheses. That is f of g of x. So f of g of x, which is frequently shortened to f little circle g. And I've always thought of the little circle as being of, but I'm not sure. I just think f of g. And so this is the notation used because sometimes all these parentheses get to be a bit much, especially first thing in the morning if you haven't had any coffee yet. But basically, what composition of functions is we're going to take one function and put it into another function. Very exciting. So there's a concept called function machines. And the idea is that, for example, you can put x into the function machine. And if the function machine is g, then what you get out is g of x. So the question then becomes, well, what is f of g of x? Well, what happens is you put x into the machine that is g, just like we did before, and we get out g of x. And then we put it into a different machine that is f, and we get out f of g of x, like that. So interestingly enough, if I say f of g of x, we actually apply g first and then f, which is a little confusing if you're used to reading things left to right, because math reads left to right, except that order of operation says, yes, left to right, but even more importantly, inside to out. So we start x, then g of x, then f. So f of g of x means we take x, we apply g, and then we apply f. If we took x and we put it into f first, and then took that and then put that one into the g machine, then we'd get out g of f of x. Kind of woohoo? Okay, so let's go ahead and look at a couple of examples. Woohoo, examples, they're the best. So I'm going to start off with f of x equals 3x and g of x equals x squared. So two perfectly reasonable functions, and we want to find f of g and its domain. So let's look at f of x, which is just 3 times whatever we give it. And the domain here is, hopefully feels very comfortable. It's all reals, because 3 times a number, not going to have much problem. You may not know how to multiply by 3, but we can find a computer or a calculator that can. It's not going to run into any big problems. G of x is x squared. Now, a little bit more exciting, same situation. Domain, all real numbers. So now what happens when we put them together? So remember that f o g, or f composed with g. I know I read it as an O, but it's open circle. So f of g, remember, is f of g of x. Now what I find easiest is to go ahead and substitute in for the g of x. So the g of x is x squared. So that means f of x squared. So right here, the g of x is actually the x squared. And then I have to think, okay, what was the rule for f? The rule for f was whatever it gets in, it spits out 3 times that thing. So if it's getting in an x squared, it's going to spit out a 3x squared. And then the nice thing here is the domain, just 3x squared. Again, all real numbers. Woohoo. Okay. Oop, maybe, well, let's see. I'll give myself a little space. There we go. So g of f. G of f. G of f of x. Okay. So that means g of, and f of x is 3x. So I need to find g of 3x. Now, pardon me. Sorry about that. G says whatever we get in, we spit out squared. So if g gets in 3x, we spit out 3x, the quantity squared, which is going to be 9x squared. Now, the good news is the domain is all real numbers. Woohoo! But the interesting thing to notice is that f of g and g of f give us two different answers. And that's important to remember. We're frequently going to get two different answers. So does it matter which one comes first? Absolutely. Now, could they be equal? Yes, sometimes that does happen. Okay, shall we go on to some more? Dun, dun, dun. Oh my goodness, there's no problem. I guess we're all out of math. We can go home. Oh no, there's some math. Okay, another problem, because really composition of functions is most easily done with examples. So I've got f of x, which is 2x, and the domain of f is all real numbers, because again, 2 times a number. Now g of x is starting to get interesting. It's 1 over x. The domain of g is a little bit more exciting. What is the domain of g? Domain of g is don't let x be 0. And don't let the pigeon drive the bus. But mostly, don't let x equal 0. Okay, so now when we mix these two crazy kids together, we're going to get something really interesting. So it wants us to find f of g and g of f. So f of g looks like this, which means it's f of g is 1 over x. So far, so good. And then what does f tell us to do? Well, g tells us to take 1 over x, which we did. And f says whatever you get in, multiply by 2. So we're going to multiply 1 over x by 2, which we could write as 2 over x. It's probably the easiest way to write it. And so the question is, what is the domain of this? And the domain of f of g is don't let x be 0. So it retains the memory of this problem. Now, is it always this easy? No, not necessarily. But this is just the beginning. We're just getting started. Woohoo. Okay, g of f. Dun, dun, dun. So f of x is 2x. So I want to find g of 2x. And g says, take whatever you get in and stick it under 1. So if I've got 2x, I want to do 1 over 2x. Now, again, notice, a little bit different from the previous answer. So f of g and g of f, slightly different. However, tell me about the domain. And in this case, it doesn't matter that the 2's in the denominator or the 2's up top. 2's generally don't cause problems for domains. What's causing the problem is that x in the denominator. So don't let x be 0. Woohoo. Okay, so now we're going to go on to a slightly different way to look at it. What we've been doing so far is composing the functions. And so I've asked our tree along, who is famous for their ecology, because we're going to decompose. Dun, dun, dun. No, we're not going to decompose it. But recognizing composition of functions. I don't think anybody else calls it decomposing. But basically what you're doing is you're going to say, okay, if I have g of f and it's 1 over x plus 2, can I stretch it out? Can I kind of tease out what g and f could have been. Now, in fact, once you start playing with this, there are an infinite number of possibilities. Seriously, you can start playing with the format and realizing that, oh, I see, this is going to be like this. So, what is the trivial example? Well, there are a couple of them, but basically, and I'll remind you, trivial means an example that technically follows the rules, but doesn't actually give any sort of insight. It doesn't do anything really interesting. It's just the basic, and sometimes kind of feels a little bit silly maybe, or useless. But it is important in this case. I would say that one of the examples is if f of x equals x, which means don't change anything, and g of x is 1 over x plus 2, then g of f of x is g of x, because in this case, f of x equals x, so wherever I see f of x, I just stick in x. So in other words, f says don't do anything, and that means that g does all of the heavy lifting. So you can always set up a situation where you can pull these apart. You can tease the two functions apart in a composition or a decomposition by setting one of them to be x. So in other words, one of them just says, yeah, do that. And so it's I guess interesting. It is an answer, but it doesn't really help. So let me suggest another example. And one of the ways to break these up is to think about them in parts. So if I have 1 over x plus 2, what if I took the x plus 2 and I made that the f of x? And then I made g of x. So f of x says add 2 to whatever you've got, and g of x says stick whatever you get in the denominator. So then g of f of x would be g of x plus 2, and if g of x is 1 over x, it says stick it in the denominator. If it gets x plus 2, it says fine, stick it in the denominator. So that's one of the more simple ways to set this up. Now, what other exciting things could I do? Well, there are lots of things. You could have one function add 5 and the other function subtract 5. So you can play with a combination of functions where they effectively do interesting things and then undo them. So there's lots of variation. Generally, it's great if you recognize the trivial example, in that one of them could be just x, and then also are able to come up with another meteor example. Not an example of meteors, which is different. A meteor, like something to sink your teeth into. Okay, so f of g is the cube root of x minus 5. And I would try to encourage you to think about the inside and the outside. I think the inside function is x minus 5, and the outside function is the cube root. In the same way that the inside function here was x plus 2 and the outside function was the 1 over. So what if we set, now keep in mind this is f of g of x. Always double check that you know which one is the inside function, which one's the outside function. G is on the inside. So what if we set g of x to be x minus 5 and f of x to be the cube root? Then f of g of x would be f of g of x says take x minus 5. Okay, so subtract 5 from whatever you've got. So x minus 5. And then f says whatever you get in, where's f? There we go. Whatever you get in, put it inside a cube root. So if I get x minus 5, I'm just going to put it inside a cube root. And that's it. So that is how you compose and decompose. Now, obviously, this is just the beginning. You're going to have tons of extra problems in your homework to practice this of variable difficulties. So if you get to one, there are some of these that are just like, what am I doing wrong? So give it a good try. But if you get to the point where you're just frustrated and you don't seem to be making any sort of headway in the problem, please take a break. Go out and look at nature, run around, frolic, sing, dance, play video games, nap, whatever. Do some art, do some science, do some chemistry, watch some interesting smoke. And then come back, ask me questions, ask the tutors questions, and know that we really, really mostly just want to help you understand and see you succeed. And we think you're amazing for giving it a try, because this stuff is not easy. So, good luck, make good choices, and math on.